One of the most powerful earthquakes ever recorded hit Japan back in 2011. It triggered a massive tsunami, forced people to evacuate, and took thousands of lives. Then, about 15 minutes later, GPS data showed something strange. Japan had moved. Physically moved. The ground under roads, houses, hotels, everything had shifted east. And that shift was permanent. For years, scientists tried to understand exactly why Japan ended up in a slightly different position. Now, they may have finally found the answer. It all started with the Tohoku earthquake, also known as the Great East Japan Earthquake. Back in 2011, the Pacific Plate suddenly slipped beneath the plate carrying northern Japan. That movement triggered a magnitude 9 earthquake off the northeast coast of Honshu, near the Japan Trench. It quickly became the most powerful earthquake ever recorded in Japan, and today it's considered the fourth most powerful quake ever recorded in the world. More than 120,000 homes were completely destroyed, and sadly, more than 19,000 people lost their lives. The thing is, this disaster was much bigger than just the ground shaking. The Tohoku earthquake happened in a region known for strong seismic activity, and also for the risk of major tsunamis. So, about 30 minutes after the huge quake, the thing people feared most actually happened. It triggered a massive tsunami, with waves that may have reached up to 133 feet high. The tsunami hit Japan's Pacific coast, spreading across more than 1,000 miles of shoreline. People only had a few minutes to react after the warning system went off. Many were desperately trying to follow tsunami safety procedures and get to higher ground. Panic was everywhere, and just when it seems like things couldn't get worse, they did. The tsunami also caused the well-known Fukushima Daiichi nuclear disaster. Basically, the water knocked out the plant's cooling systems. That led to 3 nuclear meltdowns and radioactive contamination. People living within about 12 miles of the nuclear plant were told to leave their homes. From the earthquake to the tsunami, the worst part of the disaster unfolded in about 40 minutes. And then, things got weird. You see, earthquakes happen when tectonic plates suddenly slip along a fault. That movement can change the position of the rocks on both sides of it. So, yes, parts of the country can end up slightly shifted after a major earthquake. It's supposed to be temporary, but that's not what happened in Japan. After the strongest shaking was over and the seismic waves had passed through, scientists expected the ground to settle back into place. But it didn't. Instead, GPS data still showed that parts of Japan were slightly farther east than they had been before. At first, the explanation seemed simple. Maybe it was just a glitch. Maybe the data was still being processed, or something had gone wrong in the system. But when researchers tried to correct the data, the shift was still there. That suggested Japan really had moved, and that the change was permanent. Then they noticed something else. The ground seemed to shift after a second seismic wave reached Japan, one that happened about 13 to 15 minutes after the big Tohoku earthquake. And what's curious is that scientists missed this event for many years, mostly because the signal was really hard to detect. One reason is that seismic instruments are usually set up to catch the sharp, fast signals produced by regular earthquakes. But this signal came from deep inside the Earth. It was slower and easier to overlook, especially with all the noise that followed a magnitude 9 earthquake. Then there was something else. A little movement after a major earthquake is pretty common. It can happen because of aftershocks, or because nearby faults keep slipping a little after the main event. So, at the time, scientists probably didn't see this seismic wave as something unusual. But recently, they realized the signal was actually special. It didn't look like anything they had seen before. I mean, there was no earthquake that matched the timing, so something else had to be causing the movement. And since the glitch explanation no longer worked, they started looking for the real culprit. One idea was that the main earthquake itself had caused a delayed movement at the surface. Another idea was that a huge underwater landslide had happened after the quake and helped move the land. But both explanations had the same problem. They could only explain movement close to the earthquake zone. They couldn't explain why so many parts of Japan seemed to shift in the same direction. So, researchers started looking at something known as SCS waves. These are deep earthquake waves that travel down through the Earth, reach the area near the planet's core, bounce back, and return to the surface. It's almost like a seismic echo coming from deep inside the planet. And one team came up with a theory. Maybe the Great East Japan earthquake was so powerful that these waves still had enough energy when they came back up. And according to their results, that's exactly what seems to have happened. They believe that at least one seismic wave from the Tohoku earthquake traveled about 1,800 miles down into the Earth, all the way to the boundary between the mantle and the liquid outer core. Then it bounced back up. And to give you an idea of how wild that is, the wave traveled a distance roughly like going from New York to London in only about 15 minutes. When the wave reached Japan again, it may have given the country a second little push. Not a huge one, of course. We're talking about less than a quarter of an inch. But that was enough to slightly nudge parts of the land eastward. Because as this powerful wave came back up toward the surface, it may have disturbed plate boundaries around Japan at the same time. One of those boundaries is near the area where the main earthquake happened, between the Pacific Plate and the Okhotsk Plate. Another one is farther south, between the Philippine Sea Plate and the Eurasian Plate. The original earthquake may have weakened both of these areas, so when the SCS wave came back a few minutes later, those boundaries were easier to disturb. In simple terms, the return wave may have reactivated parts of the fault system, and that second push is what may have made the land move slightly east. Researchers estimate that this special wave released about as much total energy as a magnitude 7.5 earthquake. But it didn't happen in one single spot, like a normal earthquake rupture. Instead, the movement was spread across a huge stretch of plate boundary, so it caused only a little extra shaking, and the land slipped by a very small amount. According to the researchers, if this interpretation is correct, this could be the first known example of a fault slip event triggered by a seismic wave that bounced back from near Earth's core. But this is not fully confirmed yet. Scientists still need more data from future major earthquakes to know if the same thing can happen again. For now, the study shows that earthquakes can be even more complex than we thought. The danger from a giant earthquake may not always end right after the main shock. Even several minutes later, deep seismic waves could return and trigger more movement in the same area or in nearby regions. It could even trigger movement far from where the quake first happened. So, in the future, scientists may need to rethink what happens after a giant earthquake, and maybe include this kind of delayed movement when they think about earthquake risks. This study could help other parts of the world too, especially places like Alaska, South America, and Indonesia, where massive subduction earthquakes can also happen. And as Japan showed us, that movement can be small, but still permanent. So who knows? One day scientists may find that this same process has shifted other regions too.